What's happening, everybody? You were absent for the Hawaiian Rainfall cheat sheet. So let's do this, get you going, then you can go in the lab. If you ever hear the phrase prevailing winds, here's what that means. First off, if you're on a test, go right to this ESRT, or Science Reference Table. It's in there, page 14 or so. And what it means is that this is like the overall average winds that you get in a region, the belts that you live in. What the winds do and what the storm systems do, they get blown around by these. Does it mean every single day the winds are like this? No. If a storm comes through, things spin around it, things can get a little bit weird day to day, but overall on average, this is what you'll face. So you live here. And you should be taking these notes. If you need the piece of paper, come see me. So our winds in general are like out of the west, the southwest. We have, like, if you look to the Midwest, you'll see what's coming over the next day or two because things come out of the west. And in fact, this is why, like, if you live near Lake Ontario, like you do here, like the school is, let's pretend this is Lake Ontario. Not a very good drawing. But since we have westerly winds, that's why we over here on the east side of the lake end up with lake effect issues. The winds come over that warmer lake, pick up moisture, and then dump it back on top of us. If you lived over here in Canada, it's like everything should feel kind of the same, right? But it's not. Because the winds come out of the west, they don't dump lake effect here. This is all dry. As they continue to go over the lake, they give you that. So that is a function of the wind belts that you live in, right? Don't worry about drawing that if you can. So, anything, if there's questions about what does blah, blah, blah do in this area, you live between 30 and 60, that's what's happening. Now, the lab you're going to do is actually in this wind belt, you're going to be dealing with Hawaii. So as you do the lab, consider this is their prevailing wind direction. This is what the overall average winds will do. That's what storms will do. And there's like 3 questions on there that say, where is Hawaii? There it is. It's between 0 and 30. Thing number 1, cheat sheet number 2, is if you consider these prevailing winds, if there's some big geographic feature like a mountain, or this could be like the Hawaiian volcanoes, the Rocky Mountains and Sierra Nevadas. This could be even like the Tug Hill Plateau, because this happens there. You get prevailing winds coming off the water, they rise. We call that the windward side. That's a vocab word. I didn't have you write it, but we got to know it. It's the side in the wind. And then the side out of the wind is the leeward side, or leeward if you want to say that. There's vast differences, and that's the whole point of the lab, is to figure out these differences between what happens on the side that's facing the wind as it rises up the mountain versus the side out of the wind as it sinks down the mountain. And again, this is overall average winds. This is what they do most of the time. Could they come back backwards? Yes. I shouldn't even say backwards. That's not a thing. Could they come from the other direction? Yes. But depending on where the feature is on this globe, the overall average will have them coming out of these directions indicated on that reference table. Next, it's possible that you missed the previous lesson. If so, it's critical, critical, critical. And my homework for people is to go find somebody that's taken this course to ask them, what happens when air rises? And the answer is that it expands and cools. And I make people say that so much that it's kind of a running joke. I've had people tell me that like in public. Somebody yelled it to me at the Dome once. Expands and cools. Stick it in the noggin. If you weren't here for the last lesson when we said it like 20 times, here it is. This is your first go. There it is. When air rises, it expands and cools. So we combine all these ideas that there are prevailing winds, that winds come up the windward side of the mountain, and we get this thing called the orographic effect. That term, not super critical, but the thing that happens because of it is definitely critical. So here we go. Air comes off the mountains. Let's call those the prevailing winds. I'm sorry, I said mountain. Air comes off of the ocean. All right, it hits the mountain, and it's got nowhere to go but up. And as we just said for cheat sheet number 3, when air rises, it expands and cools. Now, again, this is from the previous day's notes. If you missed those, we should probably catch up too. This is a lot to throw at you at once. But all of the things that we covered that happened here, you get 100% relative humidity. I really should say, you know what I should say first is that you hit the dew point. You cool and you cool and cool until you cool to dew point, which is when you get 100% relative humidity and when condensation happens because the air is saturated. All of that is kind of like a simultaneous definition, which we did on that previous sheet. You cool to the dew point, you get clouds, is really the short story. And it's a short story that we gotta know. What color looks cloud like? How's this? Clouds form and rain forms if those cloud droplets get heavy enough. So the windward side of the mountain here tends to be the wet side. And as the air comes up and over, as it comes down this side, it does the opposite. If when it rises, it's got less pressure on it so it can expand and that cools it. When it comes down the mountain, it gets compressed. And when you compress a gas, it heats. So over here we got air sinking, which means compresses and warms. And when that happens, you're actually driving the temperature further and further and further and further from the dew point, which, as discussed in Lab 19, is what the definition of like dry air is. So this dries out this whole side of the mountain. I lived in Colorado, let's say right about here. Air would come over the divide, come down, and start sinking and drying. And it was a very, very, very dry place to live. There was no lawns. You didn't need lawnmowers. Towels on the rack would just like dry up instantly. But if you traveled, just over to this side, not that far away, there was like farms and peach orchards and things like that that can never survive on that side. So it's a marked difference with the peak being in the middle. So here's backing up and saying, what is this lab all about? You're going to see that there's an ocean. And then as it comes up the side of the mountain, it's wet. Then there's the peak of the mountain. Then as it comes down the other side, it's dry. That's what this looks like, right? Here's the block diagram of it. You got water, ocean or a big lake like Lake Ontario. Then it comes up and it's the wet side of the mountain. And then at the top is the peak. And then on the back of the peak is the dry side of the mountain. So like in map view, because you're going to be dealing with maps in the lab, ocean or lake. And then if the peak is here, we'll expect wet on the windward and dry on the leeward. I mean, look, and then the lab asks about the Tug Hill Plateau. This happens. You guys know this. You live here. Is it snowy in Pulaski? Yeah. Up on the Tug Hill Plateau, though, way, way, way snowier. Why? Because of this. When that air rises up that plateau, it's not that big, hundreds of feet, not like thousands. It's not a mountain. But hundreds is enough that as it rises up that plateau, it expands and cools, dumps all that moisture as snow. The Tug Hill Plateau maybe doesn't have a marked dry side on the far side of it because it doesn't sink down that much, but certainly where it happens, as you know, I mean, there's a ton of snow up there. As it happens, you get a lot of snow up there. All right, that'll get you ready. We'll have to talk about how to do the lab specifically, but this cheat sheet will help. It shows up on the lab over and over and over again. The conclusion, you can really like use this diagram to write your conclusion. You can copy it. So good luck with it. Thanks for tuning in. So long for now.